You all might be very curious about what cryptocurrencies are, given it's very popular these days. So let's get into it. The outline of my talk will be that first we'll discuss what cryptocurrencies are. We'll get into much technical stuff here, but then we'll come to a more abstract view of what blockchain is and discuss what consensus is. So buckle up because this is going to be an adventurous ride today. What conventional banking looks like. Firstly, there are banks which act as middlemen. So any transaction that you do, it goes through one of the banks and they finally make those transactions happen. They can see who the person you are sending the money to and who is the person who is sending the money, and then they sometimes charge automatic amounts when you make foreign transactions. So there is always this point of trust which you put on the banks so that they do all your transactions properly and correctly. But the problem is that when you trust someone, then the transactions are open to all sorts of manipulations by the bank. They can change the figures without you noticing and stuff like that. So cryptocurrencies come to the rescue here. First of all, I like to see cryptocurrencies with these two terms. First of all, that all transactions remain anonymous, so that you can send money to anyone and the name of the sender and the receiver won't be recorded. Just their public keys will be recorded, and a single person can have multiple public keys. So I can have 2 or 3 public keys, and nobody knows that this is me who is having those public keys, because those public keys are associated with secret keys. We'll see this later in the talk today. And they are also decentralized. So there is not a single party who has all the power and who will be controlling all these transactions. It runs on a distributed server setting, and the power is not concentrated to one party. How this happens is that there is a network of computers. Each computer maintains a database and records all of the transactions from beginning. So what I mean by beginning here is that there is a genesis block. Genesis block marks the birth of a cryptocurrency. So if I write a cryptocurrency today and I started genesis block at suppose 11 AM today, then the cryptocurrency is actually born at 11 AM. The first transaction that is recorded in the cryptocurrency will be recorded in the next slot after 11 AM. So the first block gets added to after the genesis block marks the first set of transactions of the cryptocurrency. Now, first we will go through some basic terminology so that we can easily get our heads around what into the content that's coming next. So, what a node is, it's typically a computer on the network. So, it's a network of computers, and we call each computer a node. Then, what a consensus is? Like I said, that it is a decentralized cryptocurrency is a decentralized currency. So, there has to be some way in which all the nodes on the network have to come into a common agreement unanimously. So this happens by the consensus protocol. So this means that if there are 2 nodes, then it should not happen that one says that my history says this and your history says it. They should be always in agreement to each other. Then there is a block. A block is just a container for transactions. Then we have a blockchain. A blockchain is a chain of blocks which has some properties which we'll see later. Then this term is very famous. In probably every news article you hear about cryptocurrency, you'll see mining, miners. So mining there's a proof of work consensus which will be covered in the later part of the slide. So it's sort of a puzzle that you have to solve, and all the nodes on the network have an incentive to solve this puzzle, because if you solve this puzzle first, you get to earn some money. And the faster you solve this puzzle, the better you have the chance to win the game and get that reward onto your hands. So that's called mining. Mining is that you're putting a computer dedicated to just solving one puzzle, which we'll see later. The miner is the person who is running those machines which are doing the mining. And then there's a fork. A fork is just like an actual fork or a tree fork. It's just a separate branch of history. This happens when our consensus protocol is not proper. So this might happen sometimes that a node receives this two pair of transactions, and actually in how cryptocurrencies work is that each block, if I take 2 pair of blocks, then there has to be one way to order them. So there should be a topological sorting that can be done on those blocks. So if there is a block B1 and B2, then it should always be possible that I can say that B1 came after B2 or B1 came before B2. It it cannot happen that both of them came in parallel. So there cannot be forks. There just has to be a linear chain. So when forks happen, we have to solve it. It does sometimes require human intervention for that. Now, what is a box? A box is a tuple of amount and public key. So if I suppose I say that I have 5 bitcoins, then I should have some blocks with the amount totaling to 5 bitcoins and my public key in that place. A transaction has input boxes and output boxes. So if I want to send money to Alice, suppose 5 bitcoins, then you will see a box here as an input transaction which has 5 bitcoins, my public key, and an output box which has 5 bitcoins, Alice's public key. So this is how a transaction works. And one transaction can have multiple senders and multiple receivers. Because as I said, I personally can have 3 accounts, 3 public keys. So I can, if I have to send 15 bitcoins, then I have 5 bitcoins in each of those accounts. So I can put 3 input transactions into one, 3 input boxes in one transaction and send them into that.
So how are the input and output boxes associated? Like input box 1 is associated with?
No, they can in any fashion between them. This definition doesn't display that thing. And then there's UTXO. You won't see this in many cryptocurrency implementations, but in many cryptocurrency descriptions. But this is something which I was specific to my work at Cryptocurrencies. So UTXO is just a set which has all the boxes which have once been an output box of a transaction but haven't been used as an input box to another transaction. So these are the boxes which are free to use. So if I send 5 bitcoins to Alice, now this is an output box to Alice. She hasn't used it, so it will remain in the UTXO set forever. Unless
irrespective of whether it has any bitcoins or not.
Yes. It can sometimes have 0. Now we'll see the definitions by figures, which is more intuitive. So these are the nodes, like each computer on the network. Then we have a blockchain. So you see, I told you that a block is a container for transactions. So if we just see this block, it has some transactions. Now this is proof of work, and these things will come later. And a blockchain is just a chain with these blocks connected together. This is a fork. So suppose that up to this point, we can easily say that all the nodes in the network were unanimously agreeing on to this view of history. But at this point, suppose I am a node and I receive one of my neighboring nodes says that this is the next set of blocks that was received after this block, and another neighbor says this one. So whom should I agree? So this is known as a fork, and you have to resolve it in some way. Sometimes we just take the longer length. So suppose this one was just 1 length and this one was 2 lengths, so I'll take this one and I'll just dump out the other one. This is how a transaction works. So there's a sender who wants to send the money to a receiver. A sender has suppose 4 boxes. These boxes have that amount. These boxes are just like notes, currency notes. So this is a transaction. So a transaction has some input boxes. So I'll just put some boxes here, and this is the output. In the output, what happens is that money gets sent to receiver. There will be some balance amount, because suppose I have to send 7 rupees and I have a 10 rupee note, then 3 rupees come back to me as well. So they are also an output to the transaction. So that is the balance amount is received here. And I also told you that there is a miner who mines stuff. So he should be receiving. There should be some incentive into putting all that power and a dedicated machine which has to do all the work. So the miner also wins some money, and that's also an output to the transaction. But the thing to note here is that this money which the receiver gets and the balance amount equals to the money that the sender sent. But this is where new Bitcoin gets created. So this is where new money comes into play. Now we have 4 properties of every cryptocurrency, as I like to see them, and we're discussing each of these properties one by one. First of all, it's untamperedness. It should be tamper-proof, but never mind. So untamperedness is that a currency which relies on cryptography should ensure that all the transactions remain unchanged. That is, it should not happen that once a transaction is happened, it's getting changed. So it just follows that atomicity property of a transaction.